welcome back to lesson 5 of Mathematics for Natural Science course. As you remember, in the previous lesson, we learned how to use truth table method to determine whether an argument is valid or invalid. Even if the truth table method is effective, it is not always the most efficient approach, especially for complex arguments. So here we will see additional methods which are faster, shorter, and wisely used in mathematical logic. So let's see one by one. Formal proof for checking the validity of an argument. Now, under this method, first we assume the premises to be true. Based on that assumption, we check whether the conclusion is true or not. So let's take an example. Show that P implies negation Q, the first premise, Q, the second premise. Therefore, the conclusion negation P is what? Valid. So if negation P is true, whenever the two premises are true, then the argument is what? Valid. So without any question, we start by assuming the two premises to be true. The first Q is true because the Q is a premise. Second, P implies negation Q, true, because it is what? Premise. So in the formal proof method, always you start by assuming the given premises to be true. Based on that assumption, we check whether the conclusion is true or false. So if Q is true, then negation Q is what? False. So in order P implies false to be true, what will be the option for P? In order P implies false to be true, what is the option for P? P must be also what? False. Otherwise, this will not be what? True. So from the first assumption and the rule of implication, we can conclude P is what? False. Unless P is false, P implies negation Q will not be what? True. So if you assume Q is true, P implies negation Q is true, that means based on our assumption and the rule of implication, P has to be what? False. So if P is false, we are looking for the conclusion negation P. So for sure, negation P is what? True. Using number 3 and the rule of what? Negation. If P is false, the negation of P is what? True. So we proved that the given argument is what? Valid argument, because whenever the premises are true, the conclusion is also what? True. Now let's add one more. Let's take an argument based on verbal statement. It says what? It is not sunny this afternoon and it is colder than yesterday. That is the first premise. If we go swimming, then it is what? Sunny, the second premise. If we don't go swimming, then we will take a canoe trip. This is the third. If we take a canoe trip, then we'll be home by sunset. And therefore, we will be home by what? Sunset. Like I told you before, when you have such kind of argument, just don't bother about the meaning of the statements. Just try to identify the key points mentioned in the argument. So in this argument, we have what? Whether the afternoon is what? Sunny or not. Whether it is what? Colder than yesterday or not. Going to swimming. Whether it is whether we take a canoe trip or not. And finally, we have what? We'll be home by what? Sunset. So how many points we have? How many points we have? Yes, we have 5 points. being a sunny, being colder, going to swimming, taking a canoe trip, and will be home by sunset. So we have 5 points in the given argument. So for each point mentioned in the argument, we need to take variable representing the points. So let P stands for it is sunny this afternoon. Q stands for it is colder than yesterday. And R, we go swimming. S, we take a canoe trip. And T, will be home by sunset. So we can convert this verbal statement of the argument into symbolic. So the first premise is what? It is not sunny. If P is it is sunny this afternoon, it is not sunny this afternoon will be what? Negation P. And conjunction, it is colder than yesterday. Q stands for what? It is colder than yesterday. So negation P and Q will be what? The first premise. Second premise, if we go swimming, related to be what? R. So if R, then what? It is sunny, which is P. So if R, then what? P. So R implies P, the second premise. If we don't go swimming, then we will take a canoe trip. We go swimming, that is R. So if we don't go swimming, that will be what? Negation R. If negation R, then we will take a canoe trip. So negation R implies S. That is the third premise of the argument. And the fourth premise, if we take a canoe trip, that means if S, then what? We will be home by sunset. If S, then T. If we take a canoe trip, means if S, then what? T. So S implies T. So we have 4 premises, and the conclusion, a statement next to therefore will be home by what? Sunset. So our conclusion is what? T. So we convert this verbal statement into what? Symbolic form. We have 4 premises and 1 conclusion. Now to prove whether this argument is valid or invalid, like I said, without any question, we assume the premises to be true. Based on the assumption that the premises are true, we check whether the conclusion T is always true or not. If T is always true whenever the premises are true, then the argument is valid. But if there is a case where T is false, whereas the premises are true, then the argument is what? Invalid. So let's start. So negation P and Q true. What is the reason? Because it is premise. So if negation P and Q is true for conjunction, you remember the rule of conjunction, both has to be what? True. So negation P as well as Q, both are what? True. So negation P true means P is what? False. So the second premise, R implies P, that is true because it is what? The second premise. So from the second point, negation P true means P is what? False. So in order R implies false to be true, the only option for R is what? False. Because if R is true, true implies false will not be what? True. So in order the second premise to be true, the only option for R is what? False. R has to be false. So if R is false, then negation R will be what? True. Negation R must be what? True. Number 2, the rule of negation and the rule of what? Implication. So the third premise, negation R implies S, true, because it is what? Premise. Always we assume the premise to be true. Based on this assumption, we check the truth value of t. So negation R implies A is true because it is what? Premise. So in the fourth step, we have negation R true. So if negation R is true, in order true implies S to be true, S has to be true. Otherwise, the third premise will not be what? A true statement. So we can conclude S is what? True from number 4 and the rule of what? Implication. So if S is true, the fourth premise, S implies T, must be what? True, because it is what? Premise. Yes, we assume all the 4 premises to be true. The first premise, second premise, third, and what? Fourth. So in the seventh step, we know S is true. So true implies T to be true. T must be what? True. From number 6 and the rule of what? Implication. So under the assumption all the premises are true, the conclusion T is always what? True. So the argument is what? A valid argument, because the conclusion is true whenever the premises are what? True. So we prove that the given argument is what? A valid argument. So this method, we call it the formal proof method of checking the validity of an argument. Now the second method we are going to see in this lesson is the rules of inference. We will see 10 rules of inference for checking whether the given argument is valid or invalid. So you need to memorize these 10 rules of inference. So by inferring these rules, we can decide whether an argument is valid or invalid. For example, if you take modus ponens, just P is the first premise, P implies Q, second premise, and Q is what? The conclusion. So P, the first premise, if it is true, true implies Q to be true, Q has to be what? True, therefore Q. So this is what? So when you have such kind of argument, by inferring this rule, you can say the argument is valid argument. So by looking the form of the argument and the rules of inference, we can determine whether an argument is what? Valid or invalid. Again, if you take modus tollens, negation Q, the first premise, P implies Q, second premise, therefore negation P. Such an argument is a valid argument. Because negation Q true means Q is what? False. If Q is false, in order the second premise to be true, P implies false to be true, P has to be what? False. If P is false, negation P is true. So in case you have such form by modus tollens, you can decide the argument is what? Valid argument. So in such a way, by looking the form of the argument and the rules of inference, we can decide whether the given argument is valid or invalid argument. Just try to read each form. So by looking the form, it is possible to determine whether the argument is valid or invalid. Here we have 10 rules of inference. Try to read again and again so that you remember the form. Once you remember the form, by mentioning the name of the inference, you can decide. Let's take example. Let P stands for asterisk poor and Q stands for asterisk sad. So P, we assume aster is poor, Q stands for asterisk sad. Then if you take a premise, asterisk poor dot asterisk sad, meaning we have two premises. PQ is given. PQ. We have two premises. So if you know PQ true, then P and Q will be true, and P or Q will be what? True. That means we can conclude as there is both poor and sad. At the same time, we can conclude as there is either poor or what? Sad. So for this, we are using the principle of injunction. If you look the form, you are given what? Two premises. As there is poor, as there is what? Sad. So if we have these two premises, we can conclude P and Q. Because if P true, Q true, P and Q will be what? True. At the same time, P or Q will be what? True. So by looking the form, such argument having the premise as there is poor, as there is sad, and the conclusion as there is both poor and sad, it is a valid argument. Even if the conclusion is as there is either poor or sad, the argument will be what? Valid argument by principle of injunction. Now let's take another. 8P stands for it is Saturday. Q stands for I will go to cinema. Having these two, if the premise are it is Saturday, the first premise, it is Saturday. If it is Saturday, then I'll go to cinema. It is Saturday, the first premise. If it is Saturday, then I'll go to cinema, the second premise. In conclusion, I'll go to cinema. So if you have this argument, two premises and one conclusion, so by looking the form, modus ponens, you can decide this argument is a valid argument. Now symbolically, it is Saturday means that is P. If it is Saturday, then I will go to cinema. That is what? P implies Q. So we have two premises and the conclusion. I will go to cinema. That is Q. So if P is true, the first premise, the second premise to be true, Q has to be what? True. Because Q cannot be false. If Q is false, the second premise will not be what? True. So the conclusion is true whenever the premises are what? True. So by looking the form, you can decide such argument is what? Valid argument by a modus ponens. Let's take a third example. Principle of syllogism. You are given premise, if the sky is dark, then it rains. First premise. If it rains, then it is cold. Second premise. And the conclusion is what? If the sky is dark, then it is cold. So considering an argument having these two premises and one conclusion, then by principles of syllogism, the corresponding argument is what? Valid argument. Symbolically, the first premise is what? We let P to be what? The sky is dark. So if P, then Q. If the sky is dark, then it rains. That means P implies Q, the first premise. If it rains, if Q, then it is cold. If Q, then R. So these are the two premises. The first one, symbolically, P implies Q. The second, Q implies R. From the principles of syllogism, P implies R will be what? True. Whenever these are true, P implies R will be what? True. So by looking the form, you can decide the given argument having these two premises and a conclusion is what? A valid argument. So by inferring the rules of inference, you can decide whether an argument is valid or what? Invalid. So these two methods, the formal proof and rules of inference, they are what? Shorter, fastest, and widely used to check the validity of argument in mathematical logic. So This is all about the prepositional logic. The next lesson we'll start a new concept about the theory of sets. Thank you and goodbye.